Jai Hind students, welcome to my YouTube channel. Students, always wish good for others. Always wish good for others. The same good things will return back in your life. That's actually the law of nature. Spread happiness, spread love, spread positivity, and these things will certainly and definitely come back in your life. So students, no doubt life is full of complications, but always try to be happy. Try to spread that positivity, right? So with that, students, let's begin today's session. Today we are going to discuss the topic density and relative density. First and foremost, we will try to concentrate on the topic of density. And before that, we must be aware of these two terms. One is mass and the other one is volume. You must be familiar with both these terms. Mass, we have discussed in detail in the previous session, isn't it? Mass of a body is actually the amount of matter contained in it. So, mass, we all are aware, it is the amount of matter, contained in a body. That is known as its mass, right? While, how do you define volume? Any 3D object, it occupies space, and that is known as volume. So actually the space occupied by a body is known as its volume. So the space occupied by a body is known as its volume. Clear, students? We are aware of both these terms. Mass, it gives the measure of the inertness of a body, that also we have discussed. Its SI unit is kg, Cgs unit is gram, right? So total amount of matter contained in a body is known as mass. Every body is made up of atoms and molecules, isn't it? So total amount of matter which a body constitutes is known as mass. While volume is the space occupied by a body. Like, take the example of a can, take the example of a bucket. It can store a definite quantity of water or quantity of liquid, isn't it? That is, it has got a certain capacity to store liquid in it. So that capacity is known as its volume. So volume of a body is actually the space which a body occupies. And students, its SI unit is meter cube. Cgs unit is centimeter cube. So, density is basically the ratio of these two terms. So, density, which is the characteristic of a body, it characterizes a body. It is defined as the ratio of the mass of the body to its volume. So, density, which is the characteristic of a body, is defined as the ratio of mass to the volume of the body. It is defined as the ratio of mass to the volume of the body. That is, mathematically, density would be given by mass of the body divided by its volume. Clear, students? So the mass of a body per unit, its volume, that gives this physical quantity which is known as density. It is the characteristic of a body. Density, students, actually denotes the compactness of matter inside the body. So actually the density represents, or it gives the measure of, density gives the measure of, it gives the measure of compactness of matter. Compactness of matter. How compact the matter is present inside that body under consideration. So that compactness of matter is measured in terms of density. Right? If I say the density of this particular body is very high, it means that the matter is much closer towards each other. It is placed compactly. While a body having low density, in that case atoms and molecules, they must be separated from each other. There must be free space between them. Like gases, in those cases the gap between atoms and molecules are maximum out of the three states of matter. In solids, the atoms and molecules are closely packed. So compactness of matter is greatest in solid and it is smallest in gas. So therefore, generally speaking, the density of solid is maximum while the density of gas is minimum, while the density of liquid lies in between that of gas and solids. So students, again I repeat, density, it is a physical quantity which gives the measure of the compactness of the matter inside the body. It is the characteristic of a body. Different materials have got different densities. No two different materials can have the same density. Different bodies must have different densities, right? And mathematically, density is measured as the mass of the body per unit its volume. So that's density. Now, regarding its SI unit then, and before that, density normally it is represented by rho. This is the symbol for rho. It's like this. It is known as rho, R-O, rho. So density, either you can denote it by small letter d or you can denote it by rho. So density is mass. We can denote it by capital M divided by V. V stands for volume. Now regarding its SI unit, students, SI unit of density. SI unit of density would be, SI unit of mass is kg. SI unit of volume is meter cube. So SI unit is kg per meter cube. So this is the SI unit of density, right? CGS unit. Let's consider CGS unit of density. Now in CGS system, this is a system where the distance is measured in centimeter, C for centimeter, mass is measured in gram, G stands for gram, and time is measured in seconds, S stands for seconds. So in CGS unit, the unit of density is, mass will be measured in gram and volume would be measured in centimeter cube. So its unit is gram per centimeter cube. Right? And students, you need to know the relationship between these two as well, right? 1 kg per meter cube. It is equal to, let's solve it. Let's try to solve it. 1 kg is 10 raised to the power 3 gram. Am I clear? 1 meter is 10 raised to the power 2 centimeter to the power minus 3. So if you solve it, what do you get? 10 raised to the power 3 multiplied by 10 raised to the power 2 to the power minus 3. I'll write it like this. It is 10 raised to the power 2 centimeter to the power minus 3. So it will become 10 raised to the power minus 6 gram, and this will give us per centimeter cube. So what will be its value? 10 raised to the power 3 into 10 raised to the power minus 6. That would be 10 raised to the power minus 3 gram per centimeter cube. Clear, students? It's a very important relationship. So therefore, 1 kg per meter cube is equal to 10 raised to the power minus 3 gram per centimeter cube. Or students, alternatively, you can write this also. 1 gram per centimeter cube is equal to 10 raised to the power 3 kg per meter cube. You can write it in this form as well. So please do remember these two very important relationships. right? So SI unit of density is kg per meter cube and CGS unit of density is gram per centimeter cube. And what's the relationship between these two? 1 kg per meter cube is equal to 10 raised to power minus 3 gram per centimeter cube. Or you can change it. 1 gram per centimeter cube would be equal to 10 raised to power 3, that is 1000 kg per meter cube. Clear, students? Okay. Now, what to do is, let's discuss the density of few substances, right? So that will give you an idea regarding the compactness of matter in case of those bodies. As I have told students, density of solid is maximum generally, while the density of gas would be minimum. So generally, this is the order. Density of solids is maximum. It is greater than the density of liquid, which is greater than the density of gas. Right? There are few exceptions as well. Like the density of mercury. Mercury, students, it's a only liquid whose density is greater than that of solids as well. Right? Let me give you some example. Density of water. It is 1000 kg per meter cube. And I have told you 1 kg per meter cube is 10 raised to power minus 3 gram per centimeter cube. So if you substitute the value, you will get 1 gram per centimeter cube. Please remember this value. The density of water is maximum at 4 degrees Celsius, and the density of the water which is maximum at 4 degrees Celsius is 1000 kg per meter cube, or it is 1 gram per centimeter cube. It will be equal to 1000 multiplied by 10 to minus 3 gram per centimeter cube. So 1000 into 10 to minus 3 will get cancelled, will be left with only 1 gram per centimeter cube, right? Second, the density of air, it is only about 1.3 gram per kg per meter cube. It's in kg. It's in kg per meter cube. So you can check water, its density is about 1000 times. Roughly it is about 1000 times greater than that of air. I am writing the values in SI. Third, density of silver. It is about 10.8 kg. It is about 10.8 into 10 raised to power 3 kg per meter cube. Right? Fourth, the density of gold. It is about 18 into 10 raised to power 3 kg per meter cube. So as you can notice, this is liquid, this is gas, its density is only 1.3. Density of water is 1000 kg per meter cube. Let us write or express the density in SI only. These are the solids, silver and gold. Their density is very large as compared to that of gas as well as that of liquid. Now, density of mercury. Students, it is 13.6 into 10 raised to power 3 kg per meter cube. Density of iron, it is about 8.8 into 10 raised to power 3 kg per meter cube. What I mean to say is that, just observe these values. Mercury, it is a liquid. Generally, the density of the solid is greater than that of the density of the liquid. But I have told you, this is the exception. Mercury, although being a liquid, its density is greater than that of iron. Its density is greater even than that of silver. So mercury is the only liquid whose density is greater than some of the solids. Otherwise, normally the density of liquid is always less than that of this density of solid. Clear, students? So this will just give you an idea. So what I mean to say is that take two identical containers having the same capacity and fill one container with water and the other with mercury and hold both of them. The bottle or the container containing mercury will weigh much more than the container containing water. Actually, the mercury will be heavier, will appear to be heavier as compared to that of water. Clear, students? How many times it will appear to be heavier? 13.6 times. Look at this value. Density of mercury is 13.6 times the density of water. Density of water is 1000 kg per meter cube. So it is 13.6 times 1000. That is, density of mercury is 13.6 times greater than the density of water. Clear? So this should give you an idea regarding the density of various substances. Okay, students, after we have finished the topic of density, let's discuss about relative density. Now the term relative, it means that we need to have some comparative study, right? Relative with respect to. So basically, the relative density of a substance is always expressed in terms of the density of water. So relative density of a substance is given by the ratio of the density of the substance to the density of water at 4 degrees Celsius. Okay. Relative density. As I have told you, this is a term which we use so as to denote the density of a given substance in comparison to the density of water. In comparison to the density of water. So it is basically the ratio. So relative density is defined as the ratio of the density of the substance, to the density of water at 4 degrees Celsius. I mentioned this. Why we use the density of water at 4 degrees Celsius? Because water at 4 degrees Celsius, the density of water at 4 degrees Celsius is maximum, and it is 1000 kg per meter cube. This is the constant value of density of water which is maximum at 4 degrees Celsius. So students, relative density of a substance is defined as the ratio of the density of the substance to the density of water at 4 degrees Celsius, which is 1000 kg per meter cube. Like relative density of mercury, it will be equal to density of mercury divided by density of water. Relative density of silver, it will be equal to density of silver divided by density of water. So it is basically the density of a substance in respect to or in comparison to the density of water. How dense a substance is in comparison to that of water. That is relative density. And as you can check, students, relative density is the ratio of two similar physical quantities. In the numerator it's density, in the denominator also it's density. So it is the ratio of two similar physical quantities. Its unit is kg per meter cube. The unit of the denominator part is also kg per meter cube. So they both will get cancelled out. So as a result, it has got no units. Relative density has no units. Right? For example, relative density of mercury, Hg, it stands for mercury. Relative density of mercury. It will be equal to density of the mercury. Density of the mercury is 13.6 into 10 raised to the power 3. It will be kg per meter cube. Divided by density of water. It is 1000, that is 10 raised to the power 3 kg per meter cube. Kg per meter cube get cancelled. 10 raised to the power 3, 10 raised to the power 3 get cancelled. So what will be the relative density of mercury? 13.6. This is the relative density of Mercury. This is the relative density of Mercury. So it has no unit. So what it means is, how do you theoretically interpret this result? It means that the density of Mercury is 13.6 times the density of water. Clear, students? So if the substance has got density greater than that of water, it is said to be heavier. While if the density of a substance is less than that of the density of water, then it is said to be lighter. Clear? In respect to the water. So one more thing we need to discuss is that relative density of a substance is also known as sometimes specific gravity. It is also known as specific gravity. So it may be represented by Sg. Relative density may be represented by Rd, relative density. So I hope you have understood this concept, student. The relative density or the specific gravity of a substance is defined as the ratio of the density of the substance to the density of water at 4 degrees Celsius, which is maximum and constant, and value is 1000 kg per meter cube. Right? So students, in order to clear the concepts in a much better way, let's discuss some numericals then. Okay students, now let's discuss some numericals based on density and relative density. Right? Okay, let's proceed with the first question then. Question number 1. A wooden block of dimensions 10 cm into 20 cm into 15 cm weighs 6.5 kg. We are supposed to calculate the density of the block, right? So let's write down the given information. Dimensions of the block is given to be 10 centimeter into 20 centimeter into 50 centimeter. So it's length, breadth and height, right? The dimensions. So what will be the volume basically? It will be equal to length into breadth into height, right? So its volume would be 10 into 20 into 50 and centimeter into centimeter into centimeter. It will give us centimeter cube. Isn't it, students? So it will be centimeter cube. 1, 2, 3 and 5 3 are 10. So there will be 4 zeros, right? Now look, students. It has to be converted in SI, means the volume is to be expressed in meter cube. So we need to change this centimeter cube into meter cube. 1 centimeter is 10 raised to 2 or 10 raised to minus 2 meter, isn't it? So 1 centimeter, it's 1 by 100 meter, that is 10 raised to minus 2 meter. So what we get is, this will be 10 raised to power 4 multiplied by 10 raised to power 10 raised to minus 2 to the power 3, it will be 10 raised to minus 6 meter cube. So it will be equal to 10 raised to power minus 2 meter cube. So this is the volume of the block under consideration, right? Okay, mass is given. Mass of the block, unit is kg, so it must be mass. It is given to be 6.5 kg. Now students, density. Just now we have discussed theoretically. Density is the mass of the body per unit its volume. So the formula for the density is mass divided by volume, right? So mass is 6.5 kg. Volume is 10 raised to minus 2 meter cube. So it will be 6.5 into 10 raised to power 2. It will be kg per meter cube. So this is the SI unit of density, which is kg per meter cube. It may also be written as 650 kg per meter cube. So students, this is the answer. 6.5, it may be written as 65 divided by 10 multiplied by 100. So it will give us 650 kg per meter cube. So this is how the density of a body can be easily found if its mass and volume is given to us, right? So we are over with question number 1. Let's discuss question number 2 then. Question number 2 is, students, we are supposed to calculate the mass of the body whose volume is 2 meter cube and density is given to be 0.52 gram per centimeter cube. So again we will make use of the same basic formula, but we need to convert this density which is given in gram per centimeter cube into kg per meter cube. So let's proceed with the second question. Okay, mass is to be found and volume is given to be 2 meter cube. Density, let us represent it by rho. Density. This is known as rho. It is given to be 0.52 gram per centimeter cube. So let's convert it in SI. So 0.52, 1 gram is 10 to the power minus 3 kg. 1 centimeter is 10 to the minus 2 meter to the power cube. So what we get is 0.52 multiplied by 10 to the minus 3 kg divided by 10 to the power minus 6 meter cube. Right, students? So we get 0.52 into 10 to the power 3. 10 to the minus 6. When it goes upwards, it will become 10 to the plus 6. So when base are same, then the exponents get added up. So we'll be left with 10 to the 3 and units would be kg per meter cube. So this is the density in SI, in kg per meter cube. So students, you can remember 1 gram per centimeter cube is equal to 10 to the power 3 kg per meter cube. So this is a very important relationship. Please do remember, right? 1 gram per centimeter cube is equal to 10 to the power 3, that is 1000 kg per meter cube. So we are supposed to find out the mass. So we are aware density is equal to mass divided by volume. This is the formula. Therefore students, mass of the body would be equal to density, that is rho multiplied by volume. So what is the density? 0.52 into 10 to the power 3. What is the volume? Volume is 2. So what we get is 1.04 into 10 raised to the power 3. And in SI, the unit of mass would be kg. Right, students? 0.52 into 2. That will give us 1.04. Multiplied by 10 raised to the power 3. So that will give us 1040 kg. So this would be the mass of the body under consideration. So density is mass over volume. So if out of these three physical quantities any two are given, then the third one can be easily determined by using this formula. Right? So we are over with question number 2 as well. Right? Let's proceed to the next question, which is question number 3. Question number 3 is a pretty important one actually. Let me read the question for you. The mass of an empty bucket of capacity means volume, 10 liters is 1 kg. Find its mass when it is completely filled with a liquid of relative density 0.8. So this is a very good question. So first and foremost, mass of the empty bucket, let it be M1 and it is given to be 1 kg, right? And what is the capacity? Capacity means volume of the bucket, that is 10 liters. Now look, the SI unit of volume is meter cube. So we need to convert liters into meter cube. Just do remember this, students. This is again a very important relationship. 1 liter is equal to 10 raised to the power minus 3 meter cube. Right? Please do remember it. So volume or the capacity of the bucket would be 10 multiplied by 1 liter is 10 raised to the power minus 3 meter cube. So it will give us 10 raised to the power minus 2 meter cube. So this is the mass of the empty bucket and this is the capacity of the bucket, which is the volume of the bucket, the volume of the liquid which the bucket can store, right? Now, we are supposed to find out the total mass of the bucket when it is completely filled with a liquid of relative density 0.8. Now what will be the density of the liquid then? Density of liquid, it will be equal to the relative density multiplied by the density of water at 4 degrees Celsius. So density of liquid would be relative density of the liquid multiplied by the density of water. Density of water at 4 degrees Celsius. We have already discussed why we consider 4 degrees Celsius. It is at 4 degrees Celsius that the density of water is maximum, which is 1000 kg per meter cube, right? So, what about the density of the liquid then? Relative density is 0.8 and density of water is 1000. So, units would be kg per meter cube. So, what we get is 800 kg per meter cube. So, this is the density of the liquid under consideration. So, students, let's calculate the mass of the liquid inside the bucket. So, mass of the liquid, say M2, it will be equal to volume of the liquid multiplied by density of the liquid, isn't it? So, what is the volume of the liquid stored in the bucket? Whatever is the capacity of the bucket, the same would be the volume of the liquid stored inside the bucket, right? So, it is 10 raised to power minus 2. What is the density of the liquid? It is 800. So, it will be 8 kg. So, mass of the liquid contained in the bucket is 8 kg. Mass of the bucket is 1 kg. And we are supposed to find out the net mass. So, therefore, total mass, it will be equal to the mass of the bucket plus mass of the liquid stored in it. So, mass of the bucket is 1 kg, it's already given, and mass of the liquid, that is obtained to be 8 kg. So, total mass would be 9 kg. So, students, this will be the answer, right? So, this was a very, very interesting question. It's a question based on relative density. The relative density, as we have discussed theoretically, it is the density of the substance divided by density of water at 4 degrees Celsius. So that's relative density. Okay. Now, let's proceed to the last question. I think these questions are more than sufficient so as to make the concepts of density and relative density clear. Okay, last question is again based on relative density. The relative density of silver is, let me represent relative density by RD, and as I've told you, it is also known as specific gravity. It is also known as specific gravity. So it is given to be 10.8. The density of water is, this we are aware, density of water is 1000 or 10 to 3 kg per meter cube. We are supposed to find out the density of silver in SI. So this is the formula. Relative density or specific gravity. It can be written as Sg, and relative density may be represented by RT. It is given by density of the substance divided by density of water at 4 degrees Celsius. We are supposed to find out the density of the substance. So therefore, density of the substance would be relative density multiplied by density of water. So therefore, density of the substance would be equal to relative density multiplied by density of water. So students, relative density of the silver is given to be 10.8. Density of water, even if it is not given in the question, we must be aware of its value. Density of water at 4 degrees Celsius is 10 to the 3, right? It is 10 to the 3 in kg per meter cube. It is in kg per meter cube. So the density of the substance would be 10.8 into 10 to the 3 kg per meter cube, or 10800 kg per meter cube. So this is the answer. Clear, students? So I hope you have understood this numericals. So in this session, not only we have covered the topic of density and relative density theoretically, but we have done the numericals based on these topics as well, right? So in the next session, we will continue with this concept and we will discuss concept of buoyancy, concept of upthrust. So that we will discuss in the next session. So do join me in my next lecture then. Till then, do take very good care of yourself and always be happy. Thank you.